We just finished talking about operations with functions, and now we want to talk about function composition. So with function operations, you would split those guys up, f and g, you would do their individual evaluations, and then you bring the answers back. So you might plug 5 into both f and g, you do f of 5, you do g of 5, and then you bring the answers together. Function composition doesn't work that way. Function composition works more like an assembly line. So you're going to see this little notation here, a little raised open circle. So f of g of x is literally f of g of x. And so what happens here is the input doesn't get to go into both f and g. The input goes into g, and then g does what it does to it, and then that output is what gets plugged into f. I know it sounds kind of crazy, but if you just imagine an assembly line, right? And maybe you've got two different people. One person puts wheels on it, on like a toy, and the other person paints it red. So if something comes down, this guy's going to put wheels on it, this next person's going to paint it red. So he doesn't paint it red until the wheels are on there, until he's changed whatever's coming down the assembly line. But if you swap the order, if you get painted red and you put wheels on, the outcome's going to be a little bit different, right? And so we have to pay attention to the order here. So let's take a look at this example. F of x equals 5x plus 6, and g of x equals negative 4x plus 9. Both of these guys are having you evaluate this at 3, but the order is slightly different. So let's start with this guy right here. So let's make sure we understand that f of g of 3 means that we're going to find f of, and I like to use my blue for g, so we're going to do g of 3 like this. So what's going to happen here is that you're not going to find f of 3 because 3 is going to go into g first. And then whatever g gives you, that's what you're going to plug into f. So off to the side, like we do, we're going to find g of 3. So g of 3 is, according to this, negative 4 times 3 plus 9. So we have negative 12 plus 9 equals negative 3. So f doesn't get 3. F is going to get the value negative 3. And so now let's figure that one out. So coming over here to this side, we now need to find f of negative 3. So here we go, right here. This is 5 times negative 3 plus 6, and just crank this out, and we get negative 9, right? So all of this work to say that we get negative 9 here at the end. So as 3 is coming down the assembly line, 3 goes into g first and becomes negative 3. And then that's what f sees. F sees negative 3, and he gives you negative 9. So in this case, f never sees the original input value of 3. Now let's swap this order around and see if it does make a difference. Let's do g of f of 3. Well, in this case, that means we're doing g of, you guessed it, f of 3. So 3 is going to go into f first, this case, and then the output of f is what you're going to plug into g. So do some work over here to the side. So f of positive 3 means 5 times 3 plus 6. Whoops. That's 15 plus 6. I was about to just write the answer instead of showing my steps, so we get 21. All right, so we have g of 21. And now off to the side, let's evaluate g of 21. All right, so that means negative 4 times 21 plus 9. We're just going to crank this out. So that gives me negative 84 plus 9, which gives me negative 75. So you see that we get two completely different answers depending on the order that we take. If 3 goes into G first, and then F, we get -9. But if 3 goes into F, and then that goes into G, we get -75. So the order here is very, very important. Alright, let's do a few more examples in the next video, and then we're going to do some other stuff and talk about domain again.